Good morning. I'm Haibo from China open source group, and today I will share our recent work on adding the Solo5 as a new platform to the Unikraft project. Okay, firstly, we will have a overview of the Solo5 and Unikraft project, and then I will share more information about the works we have done, and finally the problems we have currently encountered. So for the Solo5, it's also known as the UKVM, and it's originally started as a project from the IBM, and it is previously used to port the Mirage OS to run on the Linux KVM hypervisor, and since then it has grown into a more general sandbox environment to suitable for running applications, and also targeting for different kind of sandboxing technologies on diverse hosting environment, and it is essentially a middleware interface in Unikernel style applications with their local host system. It can be used as a standalone product. Here is the software stack of the Solo5, and it mainly includes two components, the Solo5 tenders and the bondings. The bondings is a limited collection of APIs to provide the service to the Unikernel. And for example, the block read and write APIs will provide the block device access service. And for the tenders, it is responsible for tending to the loading and the Unikernel applications at the loading and running time. Solo5 does support several tenders, and the two most important of which are HVT and SPT tenders. For the SVT tenders, which is short for the hardware virtualization tenders, is loosely equivalent to the QEMU in a KVM QEMU setup, but it is several orders of magnitude smaller in the code size than that of a QEMU. And for the SPD tenders, which means the sandbox, the process tender, it is responsible for loading the Unikernel into the memory and install a secomp filter, and finally passing the control to the applications. The secomp filter is a strict whitelist, allowing access to a minimum set of system code, which is required to run the application. Conceptually, if you think of the Unikernel as a user-space process, the Solo5 redefined the interface between the operation system and the process. It is designed in a way that it should be as thin as possible, and thus have a minimum attack surface, which would make the Solo5 based application more secure. And it is also featured as a fast boot time, usually within 10 milliseconds. And this is very suitable for some use cases like function as a service. And it provides limited guest-facing APIs to the Unikernel applications. This would make it easy to port in existing and future Unikernel apps, as well as to support different hosting environments or hypervisors. To help finding and resolving some software problems with a guest application, the Solo5 also supports live and post debugging of a running Unikernel. Or when a Unikernel got crashed, it also shows the code dump information. Besides the aforementioned features, there are some limitations for the Solo5. And first, it doesn't support symmetric multiprocessing, and it is preferred to run scale out by running multiple instances. And it does not support interrupter and schedule because without an interrupter, it implies more deterministic behavior of the application. And this would allow the efficient record and replay of the Unikernel application. And so for the Unikraft project, I think Simon has given a very elaborate introduction this morning. And so I think we can skip most of it here. And as far as I can see, Unikraft can be treated as an evolution of the Unikernel, or we can call it a Unikernel SDK. I think the ultimate goal of this project is to make the porting effort for the Unikernel application more easier, and it prefers the recompiling of the current application rather than rewriting them when porting them to the Unikernel applications. So, in our world, Unikraft, I think Unikraft is able to build a specialized OSs and Unikernel targeted at specific applications without requiring the time-consuming expert work. So the main idea behind the Unikraft is it provides many libraries that may be used in the current applications, and there are some libraries are architecture specific or maybe platform specific. It also includes a build tool and a menu, which allowing users to pick and choose from this library more easily. The configuration and the build process are driven by a menu system like that in Linux kernel, and which make it easy to choose different libraries and configuration. I think these tools simplifies the process of try out different configurations in order to extract the best possible performance out of a particular application. Okay, for the work we have done, as mentioned in the previous slides, Solo5 can provide a general execution environment, which is very suitable for running applications built using various unikernels. And Unikraft is an automated system for building specialized unikernel-based applications. So to run the Unikraft applications on the Solo5 is possible and very straightforward. The total code is around 1,000 to add some basic support for the Solo5 to the Unikraft project. And we just need to follow the developers' guidance to re-implement some platform-specific APIs using the Solo5 bundles. Like, for example, we have to implement the platform read-write using the Solo5 bundles read-write APIs. It's very straightforward. And currently we have verified the porting on both the x86 and the ARM64 platform. And the first version patch sets has been sent to the community for review, and the second version is still work in progress. One thing I want to mention here is the resulting binary size is very smaller. For example, for the SPD tenders, the monitor size is around about 65 kilobytes, and the Hello World binary application is almost the same size. So even though we have enabled most of the platform APIs, we do have some very tough issues remain to be fixed to support some advanced platform functions like spin lock and thread context switch. As mentioned before, Solo5 does not support the interrupt, so we have to figure out a way to support the network and the block device operation. As far as I can see, we can try to use the event loop to support the network and the block device operation. Because Solo5 has provide APIs called Solo5 Por. We can use the Por loop to implement the device operation. But for the other APIs, we currently don't have idea yet. So if you guys are interested or have some ideas, we are very welcome for the proposing and patch. So that's all our works. And any question? Okay, thank you.